So this word, and I'm going to go over the notes for section 7.1 matrices equations. So what we're going to say is we're going to matrices in identified order. We're going to perform elementary row operations with matrices. We're going to use matrices in Gaussian elimination to solve system equations, and then we're going to use matrices in Gaussian coordinate to solve system equations. So first, let's talk about what a matrix is. A matrix is an array of numbers. It's rectangular. You have rows, you have columns. The rows go across, columns go up and down. Everything in the matrix is called an element. And to identify a specific element, we identify by what row it's in and what column it's in. So if I'm looking at this element right here, you can see that it's identified as element 3, 2, which means it's in row 3, column 2. To write the order of a matrix, you're going to take the number of rows times the number of columns. So what does that look like? So if I have, I'm going to go to D first because I can see the top. If I'm looking at T and I want to tell me the order, then first do the number of rows. So I have 1, 2, 3 rows, and then the number of columns, 1, 2. So this is 3 by 2. If I look at A has one element, so it has 1 row, 1 column. So let's say 1 by 1. We're looking at B, I have 1 row, 1, 2, 3, 4 columns, so it's a 1 by 4. If I look at C, it's a square matrix because I have 2 rows and I also have 2 columns. So that's called a square matrix for the number of rows equals the number of columns. When I look at E, I have 1, 2, 3 rows, 1, 2, 3 columns, so it is a 3 by 3. Again, it is a square matrix. And now, after your question for Ed Plus, so I'm going to give you a second and ask you what order is. And hopefully you guessed 1, 2. It's a 2. 1, 2, 3, 4. It's a 2 by 4. So hopefully that is the answer you selected. If I have a matrix, the most commonly used matrices when I'm looking at system equations is called an augmented matrix or augmented matrix. So if I have this system here, which is x plus y plus 3 is equal to 2, which is x minus y plus 3 is equal to 1, this is written with my variables x and y. To write the augmented matrix, I'm going to look at just the coefficients. So when I look at the coefficients of x, I have 1, 2, and negative 1. That becomes my first column. When I look at the coefficients of y, I have 1, negative 1, and 1. 2, that is my second column. When I look at my z, I have z, 3z, negative 1. That is my third column. And finally, my answers, 2, negative 1, 4, become my fourth column. The augmented matrix, in this case, for a 3 by 3 system, is 3 rows and 4 columns. It's not a square matrix, and it's designed to be that way because I have that extra column for my answers. If sometimes you want to do what's called a coefficient matrix, the coefficient matrix just has the coefficients without the answer. So it's just this part of the matrix to become the coefficient matrix, and this would be 3 by 3. The coefficient matrix should always be a square matrix. In other words, it should have the number of rows equal to the number of columns. So number 3 says write the augmented matrix for the system of linear equations. So all I'm going to do is I'm going to identify my coefficients x, my coefficients y, and my coefficients z. Now some people find it helpful to write the x, the y, and the z above, and you can do that. So here would be my x column, my y column, and my z column, and then I have my answers. So when I write this, my coefficient of x is 1, my coefficient of y is 3. In the first equation, I do not have a z, so I'm going to put a 0 there to hold that place, I'll put that element spot, and then I'm going to put a 9 for my answer. When I go to the second equation, I have a negative y, so negative 1, 4z is equal to negative 2. I have to put a 0 in there to keep track of that place. And then the last one, last equation, I have negative x, so negative 1, 5z, so the 5 will go here because it's z, and 0 is my answer, I have to put a 0 in here to both places. So this is my augmented matrix. And to separate my answers from my equations, you usually put some type of symbol in there. I usually put the 3 dots. That separates my coefficient matrix from my answer matrix. So remember here, if I ask you for coefficients, these numbers here are my coefficients, and this last column here is my answer. So that's the augmented matrix, and that's all they wanted us to do for number 3, was to write the linear equations, linear equations as an augmented matrix. When I look at the row echelon form and reduced row echelon form, I'm going to use my matrix to solve my system equation. So here's the steps that it gives me. It says for any rows consisting of entirely of zeros, it first divides into the matrix. For each row that does not have consistent entirely of zeros, the first non-zero entry is a 1, called the leading one. For 2 successive non-zero rows, the leading one in the high row is further to the left. So what that means is you're getting something in what's called reduced row echelon form. You're going to have a 1 here, and then zeros, and then a number. And then 0, 1, 0, number. 0, 0, 1, number. That would be reduced row echelon form that has this zigzag or the coefficient. You want everything else to do. That is reduced row echelon form. Reduced row echelon form. Sometimes you have 1 and then you can have a whole bunch of other numbers here. And then I have 1 here. And I'm just making up numbers. And let's say I have like 60. Whatever these numbers are. It doesn't really matter. Here, these are all 1s. And then everything below that column of 1s is 0. This is called row echelon.
Page draw to the opposite.
It's not reduced row echelon form, it's row echelon form. So you have to read the directions to see which one you're going to do. Normally, we put everything in reduced row echelon form. So we're going to go back to that pattern that we had in the last section, where we learned how to solve, where we have the R1, R2. And we're going to stick with the same thing, but when it says eliminate the X, we know we're going to eliminate the number in the X column. When it says eliminate the Y, we know we're going to eliminate the number in the Y column. So let's just try and do one. So example 4 says write the augmented matrix for the system of linear equations to begin with. So I'm going to start with my 1, 3, 4, 7, 2, 7, 5, 10, 3, 10, 4, 27. So that's my augmented matrix. This is my X column, my Y column, my Z column. These are my answer columns. This is my first equation, second equation, third equation. That's the augmented matrix. Now, if I go back and I follow this pattern that we did before, I'm going to do row 1 and row 2 to eliminate the X. So in this case, I'm going to do row 1 and row 2. I'm going to do row 1 and row 2 to eliminate the X, in other words, to eliminate that 2. So in order to do that, I'm going to decide row 1 is going to stay this. Row 1 I'm going to multiply by -2. So it'll be -2, -6, -8, -14. Row 2 is going to stay the same, so 2, 7, 5,
Page draw.
10, and I'm going to add. So this will be 0, 1, -3, -4. So that's going to become my new row 2. And what I'm going to do is I'm going to, and I might want to break this. So row 1 hasn't changed at all. And then this is going to be my new row 2 is 0, 1, -3, -4. And then by my new row 3, I'm going to go back to this pattern, which says I'm going to do row 1 and row 3 to eliminate the X. So I'm going to multiply row 1 by a -3. So -3, -9, -12, -21. I'm copying down row 3. I'm not going to change that at all. So that's going to be 3, 10, 4, 27. I'm going to add,
This
row 1, -8. I'm going to look up here and I'm going to do row 2 and row 3 to eliminate my y. So I'm looking at my new row 2 and my new row 3, and I want to eliminate my y, so I want to eliminate this right here. So if I want to eliminate this, I'm just going to multiply it by negative. So why don't we take negative row 2, 0, negative 1, positive 3, positive 4, copy row 3 down the way it was, so 0, 1, negative 8, positive 6. And when I do that, I get 0, 0, negative 5, 10. Now when I'm here, I only have one number to the left of those dots. So I'm going to want to find out what that is. So I'm going to divide by negative 5. So I'm going to divide both sides by negative 5. 0 divided by anything is going to stay 0. So this will be 1 and then negative 2. So when I write this, this first row has not changed at all. I haven't changed it at all. This one only changed once. And now I have this, which is 0, 0, 1, negative 2. Which, if I wanted to go backwards, remember this is my x, my y, and my z. This means that z is equal to negative 2. Now, I'm going to continue, put that like a little pause and put that there. And I'm going to continue with this formula. So I've just done 2 and 3 to eliminate the y. Now I'm going to do 3 and 2 to eliminate the z. So I'm doing this row and this row to eliminate this z here. So I'm going to multiply row 3 by 3. 0, 0, 3, negative 6, and then row 2 will be 0, 1, 3, negative 4. And when I add these, I get 0, 1, 0. Pause for a second. 3. Oh, yes. Okay, 0 and negative 10. So now I have 1, 3, 4, 7, which hasn't changed. Now I have this 0, 1, 0, negative 10, and then 0, 0, 1, negative 2. So I know my z is equal to negative 2. I know my y is equal to negative 10. And then I'm going to go back up here. It tells me 3 and 1 to eliminate z. So it's saying 3 and 1. This is 3. This is 1, and I'm eliminating my z, which means I'm eliminating this 4. I'm going to multiply row 3 by negative 4. And then negative 4 times row 3. And when I do that, I'm going to have 0, 0, negative 4, positive 8, positive 8. And then row 1 is going to be 1, 3, 4, 7. And when I add those, I get 1, 3, 0, 15. Now I'm going to follow the pattern. I'm going to go back up and I'm going to do 2 and 1 to eliminate the y. So if I look at row 2 and row 1, to eliminate the y, so I'm going to multiply by negative 3. And so I'm going to have negative 3 times row 2, so 0, negative 3, positive 30. And then row 1 is 1, 3, 0, 15, and I get 1, 0, 0, 45. So now I have 1, 0, 0, 45, 0, 1, 0, negative 10, 0, 0, 1, negative 2. So those answers, 45, negative 10, negative 2, are my answers, my x, my y, and my z. Because this can be written as x equals to 45, this is my y, y, 10, Alright, so that's one way to do it, and that is putting this in reduced row echelon form, which I went through all the steps in the chart, and I went through every single step, so 1, 2, 3, 4, 5, 6 steps, and I got my answers. I could do this slightly different. Once here I have this z is equal to -2, and I have this, I could at this point do what's called back substitution. So I am going to pause this for a second so I can copy this. So I just copied it down, and what I could do at this point is I know that z is equal to -2. And then this line I can rewrite as y minus 3z is equal to -4. And the top row would be x plus 3y plus 4z is equal to 7. And then I have that z is equal to -2. And then this is that stair step that we talked about, so then I can do back substitution. And I can make this y minus 3 times -2 4, so y plus 6 is equal to -4y is equal to -10. And then following I have x plus 3 times y, which is just 10, plus z, I think, plus 4z is equal to 7. And then I can back substitute that in and get x plus -30 plus -8 is equal to 7. X is equal to 45. I'm still going to get the same answers, but instead of doing those last couple steps from here down, I would just do back substitution instead. Either way is fine, depending on the directions. You know, eventually you are going to have to know how to put something in the reduced relation form for a section that we're doing later. All right, let's do an application problem. So our small corporation borrowed $500,000 for the building. They borrowed some money at 7, 8, 10%. The annual interest was $43,500, and the amount borrowed at 10% was 4 times the amount borrowed at 7%. So the same rules still apply. I'm going to have 3 unknowns. I'm going to have the amount that's borrowed at 7%. I'm going to call that x. I'm going to have the amount borrowed at 8%, and I'm going to have the amount borrowed at 10%. Since I have 3 unknowns, in order to solve this, I have to have 3 equations. So the first one's going to talk about just the amount of money I borrowed. So the amount at 7% is x, the amount at 8% is y, the amount at 10% is z. So those 3 amounts together, so the x plus y plus 3z, has to equal that $500,000, because that's how much I borrowed. The next one is going to deal with my interest. So to figure out how much interest I'm charged, I take 0.07% and multiply that by the amount that I borrowed at that for free. 0.08 would be the amount of interest I'm charged at that bank, and finally 0.10 times z would be the amount of interest I'm charged at that. Those 3 interests are equal to that $43,500. So those 2 equations are very simple. The last one is the amount borrowed at 10%. So the amount borrowed at 10%, so z. The amount borrowed at 10% was 4 times the amount borrowed at 7%. So this z is equal to 4 times the amount borrowed at the 7%. And so when I do that, I'm going to have to rewrite that equation. So if I'm going to choose to solve this with matrices, I'm going to have to rewrite this. So I may either take the z over to this side or the 4 over to this side. It doesn't really matter as long as it's consistent. I'm going to choose to take the z over here and make the 0 subtract the z. Equals 4x minus z. So I'm going to have 4x minus z is equal to 0. And then if I put it in a matrix, I'm going to have the augmented matrix 1, 1, 1, 500,000. I'm going to have the 0.07, 0.08, 0.1, z equals 43,500. Now, I know these numbers are bigger, but it's still very doable. That's a 1. That is 1. So I have that, and then I'm going to solve. If I have something like this, I'm going to be perfectly honest. I am probably not going to keep it as a 3 by 3 and solve this. I am probably going to use the fact that right here I said z is equal to 4x. So any place I see z, I would replace it with 4x. And then that way I would knock it down to a 2 by 2, which is a heck of a lot easier to solve. So I'm probably going to do it that way. I'll give you a minute to solve it, and we'll see how you do. You can solve it any way you want, just see how you do. So hopefully you got these answers. My answers were 50,000 at 7%, 250,000 at 8%, and 200,000 at 10%. So I got the -1 here, so that's -1. So I put it in the augmented matrix, and then what I decided to do is I looked at row 1 and row 2, and I wanted to eliminate the x. So here I multiplied row 1 by the -0.07. I did that to this row. Left row 2 alone, combined it, and I got this new row 2. Now this became my row 2 here. Then I took row 1 and row 3. I multiplied row 1 by -4, so I got that. I left row 3 alone, and this became my new row 3. And there's my new row 3. Then I decided to do row 2 and row 3. And I had to figure out what I had multiplied 0.01 by 4, and I realized it was 400. So I multiplied row 2 by 400, and I got this. I added it to row 3, and I ended up with this divided by 7, and then I got this 001 is equal to 200,000, which told me that Z is equal to 200,000. And then I decided to do back substitution. So I back substituted that into this equation, my second equation, which I got from here. I just put the x and y back in. And when I did that, I got y equal to 250,000. And then I back substituted into the original row 1, which is the 500,000. Substituted those back in, and I got x equal to 50,000. Since it's a word problem, I have to kind of interconvert. So here's where I write the answer. That is one way to do it. You could have done it multiple different ways. At the end of the video, stick around, I'll show you the flip on your calculator as well. Okay, the next one, I even use Gaussian elimination with back substitution to solve the system. So this one is trying to give you a little hint, just telling you what is the first step to eliminate x and R2. You're probably going to have to write multiply by -3. So before I start this, I am going to want to rewrite the matrix as an augmented matrix. So let's do that first. So remember my augmented matrix 1, I don't have the y. And the other one is pretty straightforward. Make sure you do not drop the negative sign. So there's my augmented matrix, and now I'm going to decide to multiply row 1 by -3. So -3 times row 1, so we have -3, 0, +9, +15. Popping down row 2, 3, 1, -2, -4. When I add, it's 0, 1, 7, 11. Put that here. 1, 7, 11. You can go 1 alone. Now to do row 1 and row 3 to eliminate the x, I'm going to multiply row 1 by -2. So -2, 0, 6, 10. Row 3 is going to be 2, 2, 1, -2. When I combine, I'm going to have 0, 2, 7, 8. Then I'm going to do row 1 and row 2 to eliminate my y. So I'm going to multiply -2 times row 2. So 0, -2, -14, -22. And then I'm going to pop it down row 3, 0, 2, 7, 8. When I combine it with 0, 0, -7, and then -14. When it gets to this point, when I only have one number to the left of the dots, the separating my answers from my coefficients, I'm going to divide by whatever that is, and it's 0, 0, 1, 2. So now what I have is row 1 has not changed at all. Here's row 2, which I did not change the step, and now row 3 is 2. Now I'm going to look at row 2 and row 3 to eliminate my z. So I'm eliminating my z, so eliminating this, and we'll multiply this one by -7. negative 7 times row 3 is equal to 7. Row 2, 0, 1, 7, 11. I'm going to do 0, 1, 0, negative 3. The reason why I want it, so then the next thing it tells me to do, it tells me to do row 1 and row 3 to eliminate my Z. So I'm going to try to eliminate this, so I'm going to multiply this by this 5 3 times row 3, 0, 0, 3, 6, and then row 1 is 1, 0, negative 3, negative 5, then I get 1, 0, 0, 1. And then the last thing it tells me to do is it tells me to do row 1 and row 2 to eliminate my y. But my y here is already 0, so I don't have to do that. So sometimes you get things written, you can skip a step. And then my answer will be 1 and 2 and 2. So hopefully you were able to do that on your own before I did. Alright, so as promised, let's do the calculator trick. So I'll have the calculators out. I am going to go back to this one right here, and I am going to show you how to put it in your calculator. And this is a great way to check. So when I'm working on a problem and I want to make sure I'm doing it right, I usually check this like partway through to make sure that I have the right answer. So you cannot use it to get the answer. Remember, it's about the work, not about the answer. So pulling out my calculator, I am going to add a calculator page. I am going to hit menu, matrix vector, and then I'm going to do number 5, which says reduced row echelon form. Not 4, row echelon form will not help me at all. So I'm going to do 5, reduced row echelon form. And it gives me this symbol RREF, reduced row echelon form. That's what that stands for. I'm going to add a matrix to our calculator. So if you look at the button right next to number 9, you'll see those X's and things like that. I'm going to press that. I'm going to go to the one that looks like a 3 by 3. I'm going to pick that matrix. It says number of rows, number of columns. Well, if I look back here to my augmented matrix, I have 1, 2, 3 rows, 1, 2, 3, 4 columns. I'm going to want to make it a 3 by 4. So it already has 3 rows, so I'm going to hit tab. I'm going to go down here and I'm going to change this to 4 columns. I'm going to hit OK. It should look exactly like the one that I'm trying to fill in. Now I'm going to put in the coefficients from my augmented matrix. So I'm going to do 1. Remember, I have a 0 there. Negative 3, negative 5. 3, 1, negative 2, and negative 4. And finally, the last equation is 2, 2, 1, negative 2. So doing a quick check, I check it. It looks like I have it right. Hit enter. And what I see here is I see something that looks like a, I'm going to carry this over. So this is what my calculator gives me. So to the left, so imagine to the left of where those imaginary dots would be. So remember the imaginary dots would be here. To the left of that, I'm going to have the main diagonal ones. Everything else is going to be zeros. So that is a reduced row echelon form. And then this column here is going to be my answers, which matches the answers that I got here. So that's a quick way to check. So I take advantage of that to check. That is not good enough for your answers. But at least I normally check that or put it in my calculator before I start. So when I get my first answer, so when I get this answer here that z was equal to 2, if that's what matches on my calculator, I know I'm on the right path and I can keep on going. If I didn't get the right answer here, I only have 3 things that I have to go back and check, which is a lot better than checking the whole problem. So I hope this helps, and we'll see you next time in class.